Okay, so we've got 6.8, question 2 and 4. Did anyone have a go at those?
I can't find it.
Okay, have you all got a book in front of you?
I haven't got it.
Okay, so I'll read it out. So, in an industry where n firms producing a homogeneous product, let Qi denote the output of firm I, so little qi, little qi from I is 1 up to n. Big Q is the aggregate, so big Q is rubbish. Here's Q1 plus Q2 plus okay, it's normal. There's a demand curve, which is P is 100 minus big Q. And there's a cost function, so cost for firm I of producing quantity I is F plus Qi squared. And we've got to solve a few problems. The first one is, suppose the number of firms in the industry N is sufficiently small so that all the N firms make above normal profits. Calculate the output and profit levels of each firm in a Cournot equilibrium. Okay, so we're just holding, sorry, it's capital N firms, holding capital N fixed and working out profits. So does someone want to have a go at this on the board? You're closest.
Okay, is it Cornwall?
Yeah, cool. So profit of firm I, and it's little q, not big Q, remember. Because firm I is only selling, yeah, exactly. Firm I is only selling little q. Yeah. Okay, so you just substituted in the demand curve. There's a bracket missing there. Minus theta plus, yeah. Yeah, okay, so the maximum derivative of profits with respect to quantity is equal to 0. So he's using the product rule. So we've got derivative of this, which is 1 times this. Yeah, exactly. Plus this times the derivative of this. Yeah. Yeah. So this is Qi, and then you get a minus 1 from the derivative of this bit here, so it's minus Qi, and then the derivative of Qi minus Qi squared is minus 2Qi. That's right. Okay, so now same trick you always do for Cournot. So this holds for every firm I, so you can add all the equations up across the n firms. So you get n copies of 100, n copies of Q. You get the sum of Qi from 1 up to n, which is big Q. And you get the sum of minus 2 little q from I is 1 to n, which is minus 2 big Q, and then dividing through by n. Yeah, that looks good. And now you just have to solve for Q. Okay, so he's taken 100 across to that side, so you've got minus 100 on that side, and then on the left hand side we've got minus 1 copy of Q, minus 1 over n, minus 2 over n. Okay. All the minus signs are going to become pluses. So let's just check what you did there. So that was, so on the bottom we had 1 plus 1 over n plus 2 over n, and you're saying that's equal, so that's n over n, so it's n, so if you like, it's n over n plus 1 over n plus 2 over n, which is exactly n plus 3 over n. Okay, very fast. Okay, so you know the optimal quantity. Okay, so the question asks for profits. So you substitute optimal quantity back into
Should I
profit.
get the price as well first?
Yeah, give the price, sure.
Do you mind writing the profit stuff?
You can write it as well. Okay, so division on the bottom is the same as multiplication on the top, so you can make the n on top. It's a bit tricky. Okay, you're very fast. Let's just go through it for everyone else and for my benefit. So you've got, so 100 is just equal to 100 n over n plus 3 plus 300 over n plus 3. Okay. So you've got 100, so 100 is this thing, so minusing that one kills that one, and you're just left with 300 over n plus 3. Yeah, it's no computer. Okay, so so because all the firms are symmetric, okay, the quantity produced by firm I is just the total quantity divided by the number of firms. So just subbing in now, 300 over n plus 3 times 1 over, yeah, all of that. So that was Q7 minus cos. Yeah. And you can substitute in again for Qi squared.
That's basically this, isn't it?
Yeah, exactly. It's that. Yeah. Yeah. Squared. And it was little Qi squared. So, so you're squaring that, and what?
That thing.
Yeah, okay, that's fine. You can do it that way. now, you know, it's just a tedious bit of simplifying a bit. Because the next step is going to ask you to find n. So if you haven't simplified a bit first, the next step's going to be difficult. You know, you can kind of see already that it's likely to simplify because you've got n plus 3 squared times n here, you've got n plus 3 squared here times n squared. So I would get everything. So if you look at the, you know, you're trying to get a common denominator, right? And on this side, over here, you've got n plus 3 squared all times n squared. So if you want to get everything over that, you want to multiply the top and bottom by one of these fractions by n. Okay. So maybe make that 300n over n squared then.
I'm sure this times the whole thing. Like, expanding, well, yeah, times the whole thing and just minus this, since they've got the same denominator anyway, other than f, of course.
No, but they haven't because this is n squared and that's.
Oh yeah, that's good. Right.
So if you make it, but if you make it 300n,
Okay.
yeah, so 300,
Oh, no,
300 times
times
n,
n,
yeah.
okay.
N plus 3. Okay, so you've gained an n on the top, so let's turn that 1 over n into 1 over n squared. Yeah, and then keep everything else as it was before. You can kind of do that, yeah, put a square there.
Okay. Okay, so now everything is over the same thing. You've got n plus 3 squared, n squared on the bottom here, you've got n plus 3 squared, n squared there. So now you can put everything into one fraction. You're looking confused?
I'm trying to see the whole. Oh, okay, yep, I see.
Yeah.
Because I couldn't see the 300n with the 1 over n squared sort of came out of nowhere.
Yeah. Yeah, so we just put an n on the
Yeah.
top and we put an n on the bottom. So.
Yep.
Actually, this first.
Do you want me to take
Yeah.
over? They've suffered enough, I think.
Thanks.
Very good. So let's just put the thing on the bottom at the front. Okay, so we've got 1 over n squared, n plus 3 squared. Okay, and then we've got everything else. So here we've got 300n times 100n times 100n. Here we've got minus f, which is becomes minus f, n squared, n plus 3 squared. Okay. And then here we've got just 100 squared, minus 100 squared. Okay. So we're going to have lots of zeros. Let's take 100 out. 100 squared. That's fine. So 300 times 100 must be 300 n squared minus 100 minus f n squared n plus 3. Yeah, it's not obvious, but you can simplify that anymore. Is everyone happy with that? We haven't made a mistake somewhere.
Do you not have you not got to square the 100?
100 squared.
Oh,
yeah,
so you're taking it out of the bracket.
Should leave you to do that. Take fewer mistakes than I did.
I've printed off the answers from the book.
Okay, they get something neater, do they?
They,
Go
yeah,
on.
the first Q,
Let's-
I get 100n over 3 plus n.
Ah, it's the same thing.
So, this is 2, okay, so Q, 100n over n plus 3. Yeah, so you can take division on the bottom is the same as multiplication on the top, so that's 100n over n plus 3. So that's the same. Price, so profits, they get a nice expression for profits. Tell you what we forgot. So they want. No, we didn't. So did we get the same thing from a price? We got the same thing from a price, 300 over n plus 3. So we just haven't quite simplified profits as much as they did. Just check everything was right. Price and quantity over n. Price was that. Quantity was that. Okay, let's take F back outside the brackets. But no point. Where did I put my pen?
Under your book.
Crazy. Okay, minus that. It's the same thing. You must be able to factorise this. I think that must be the difference. So we can certainly take out 100 squared if we wanted to. So we can write that as 100 squared over n squared n plus 3 squared. So it's going to be 3n squared minus 1. So to get the answer in the book, this seems like this n squared, this 1 shouldn't be there. It should be an n squared. Where did it come from? Look.
Yeah.
Typo.
That's what you end up.
So there was an n on the top there. So this was qi in the cost, and just a minor copying error, but the n has disappeared. So there should be an n, and it's fine. I didn't spot it either. Okay, so this is now 100 squared n squared. Okay, so this is 300,000 n squared minus 100,000 n squared. Okay, which is 3n squared minus n squared. Okay, so that's just 2n squared. Okay, that looks a lot neater. So any question you get should have a neat answer. So this is going to be 2n squared. We've got n squared on the top, n squared on the bottom. That's going to cancel out. So it's just going to be 2 times 100 squared all over n plus 3 squared. Okay, which is minus f. That's what's minus f. Okay, is everyone happy? Sorry about that little slip. So that was part A of this question. It was a bit long, wasn't it? Now assume that firms are allowed to enter or exit from the industry. Find the equilibrium number of firms in the industry as a function of F. So, how are you going to go about doing that without reading the hint? So how are we going to find the... So we know profits. How are we going to find the number of firms?
Rearrange. Can we rearrange that?
Yeah, well, what do we... What's on the left-hand side?
Do you make any subject?
Yeah, okay, but what's the level of profits going to be? So it's basically free entry. Assume that firms are allowed to enter or exit from the industry. So what must the level of profits be?
0.
0. Yeah, exactly. So your selling profits equal to 0, and then you can rearrange this. Okay, so this thing here is going to be equal to 0. So taking f across to the other side, we have f is 20,000 over n plus 3 squared. So timesing by n plus 3 squared, dividing by f. You just write that as n plus 3 squared is equal to 20,000 over f. Taking the square root of both sides, n plus 3 is equal to the square root of 1,000 over f. Now this is a quadratic. It'll have two solutions. Clearly, but the second solution isn't going to make any sense because the number of terms has to be positive. So n is minus 3 plus square root 20,000 over f. And when you've done this, you should always do a kind of sanity check. As the fixed cost changes, what's happening to the number of firms? So as fixed cost increases, what happens to the number of firms?
It decreases.
Yeah, it's going to decrease. This gets bigger, so this gets smaller, so that gets smaller. So that's what you expect, right? If it's expensive to enter the industry, there should be fewer firms. And that was the exercise. And then in the next week, I suggested you look at question 4 from 6.8. I'll turn the board. So question 4 says, two firms compete in prices in a market for a homogeneous product. In this market, for n bigger than 0 consumers, each buys 1 unit if the price of the product does not exceed $10 and nothing otherwise. Okay, so consumers all value the product at $10 and we're n consumers. Consumers buy from the firm selling at the lowest price. In case both firms charge the same price, the consumers split equally between the two firms, 0 production cost. So part A says find the Bertrand equilibrium prices for a single shot game, assuming that firms choose their prices simultaneously. So what's the Bertrand price going to be?
C.
Well, marginal cost is 0.
Oh, sorry.
0.
0. Yeah. Yeah, so it's 0, price is 0, everyone's prepared to buy, so that's going to be the equilibrium. Now suppose that the game is repeated infinitely, let rho denote time discount parameter, propose trigger price strategies for both firms yielding the collusive price of 10.10 each period. Why is 10.10 the collusive price?
Because it's the monopoly price.
Why is it the monopoly price?
Can you read out the numbers again?
So for end consumers, they're all prepared to pay a maximum of $10.
Yeah.
So they're prepared to pay any amount up to $10. So yeah, kind of that's all there is to say really. There's no point charging less than $10 because if you charge $9, you don't gain any extra demand. Okay. Calculate the minimal value of rho that would enforce the trigger price strategies you proposed. Okay, so what are the trigger strategies going to look like?
So it'd be you charge monopoly price unless you observe someone charging less than monopoly price,
Yeah.
then you charge 0.
Yeah. Okay, so how are we going to work out this minimal value of rho?
The monopoly profit over 1 minus rho.
Okay, well let's write something down. Okay, so let's have periods from t is 1 to infinity, and in period t they get a profit of pi t. Okay. And this is for firm I. Pi it is so capital pi, the firm I is this infinite sum. Okay, so the total profits for firm I, we need a rho, don't we? So rho to the power of t. Write that again so it's clear. So rho to the power of t times pi I t. Okay, total profits for firm I are this discounted sum. Okay, rho is the discount factor times the profit profit firm I makes in period t. So that's starting at 0. Two mechanisms. So if they set the monopoly price every period, what's their profit going to be? So if we set the monopoly price every period, this is always equal to 10. No, so we're n consumers and they're selling at 10, so quantity is n, price is 10, so profits are going to be 10n. Okay. So if if no one deviates from these strategies, they set the monopoly price every period, demand is split equally between them, I should say. So if total quantity is n, then each of these firms are getting n over 2, because there are 2 firms. So it's like kind of Qi is n over 2 and P is 10. Okay, so their profits are going to be 5 times n. Okay, so if we put that into this thing, so this is going to be equal to t is 0 to infinity of rho to t times 5n. Okay, this is just a constant. You can take that outside the sum if you wanted. And what's this infinite sum of rows? You kind of said it earlier.
Yeah. So it's 1 minus rho.
Yeah, 1 over. So 5n over 1 minus 1. Again, the way to check this is this sum. So we've got 1 plus rho squared plus dot 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 dot. Think what happens when you multiply that by 1 minus rho. Okay. Well, you're gonna get plus 1, and then you're gonna get plus rho, but then you're gonna get minus rho, then you're gonna get plus rho squared, then you're gonna get minus rho squared, etc., etc. Okay, so everything's gonna cancel out. So all you're left with is that first term, which is 1. Okay, so
this times this is equal to 1, then this thing must be equal to 1 over 1 minus rho. So if no one deviates, they make profits of 5n over 1 minus rho. What profits do they make if they deviate?
10 in.
Yeah. So if they deviate, they set a price 1 penny below the other, everyone buys from them rather from the other firm. So in that period they get the whole market, so they get quantity of n, price of 10, so that's 10n. And then in subsequent periods the other firm's going to punish them, they're going to set a price of 0 from then on. Okay. So they're going to get 0 profits in future, so all they're going to get is their profits today. So for this to be in equilibrium, the collusive one to be in equilibrium, we need this thing, the profits we get from not deviating, to be bigger than the profits we get from deviating, which we just said were 10n, or bigger or equal to. Okay, so all we need to do is solve this inequality for rho. We can divide through by 5n, divide both sides by 5n, and this then becomes 1 over 1 minus rho has to be bigger or equal to 2. So 1 has to be bigger or equal to 1 minus rho. So we what am I doing? Minus 2. 1 has to be bigger or equal to 2 minus 2 rho. We add 2 rho to both sides, we subtract 1 from both sides, we get 2 rho has to be bigger or equal to 1, so rho has to be bigger or equal to 1/2. So they don't have to be very patient at all. In the real world we think rho is probably standard values of a discount factor are like 0.99 or something if it's quarterly data, or 0.96 if it's annual data. So this isn't very patient. Okay, so that was part B. Now suppose that the unit production cost of firm 2 is $4, but the unit cost of firm 1 remains 0. Find the Bircham equilibrium with a single shot go. So one firm has a marginal cost of $4, the other firm has a marginal cost of 0. What's the Bircham equilibrium going to look like?
4 minus epsilon.
Yeah. So $4 for all intents and purposes. So it's the price is $4, but only the firm with a low marginal cost is selling anything. So it's just below $4, like we said. Okay, so assume, and then part D says, assuming the new cost structure, propose trigger price strategies that again yield the collusive prices of 10 each period, and calculate the minimal value of rho that would enforce the trigger price strategies you propose. Someone else want to do this? Do you want to volunteer?
No.
Do you want to volunteer?
Not even slightly.
You'll volunteer.
I have to volunteer.
Yeah. Process of deduction. Okay, so one firm now has marginal cost of $4. So
Okay. Wait,
it's pretty similar to
I
what
was
we
going to
did.
say, that's not trigger price. Do I have to work? I don't have to work out rho. I just have to
Yeah,
prices.
find rho again.
find rho again.
Find the constraint on rho.
Okay. Everything has remained constant other than the marginal cost of 4 for firm 2.
Yeah. So before we even start, which firm is going to be more tempted to deviate?
Is that one?
Yeah, because if firm 1 deviates, they get profits of 10n, but if firm 2 deviates, they get a profit of 6n, right? Their marginal cost was 4, so on each unit they're selling, they're making a profit of. Is that true? But they're also making, maybe it's not so obvious, because we're also making less profits nominally. Let's go through it slowly.
Can I have
A rubber, yeah.
Yep.
then you don't need that.
I don't need the T. Subscript.
Yeah, it doesn't need that. So 4 is marginal cost, not total cost.
Ah, right, okay.
So
Four
like make
over
any
two.
quantity of n over 2.
Two.
Yeah.
G over two.
Okay, so that's for profits from not deviating. Now, what profits do I get if they deviate? Oh, you can work out what these sums are. So the top sum is just going to be what we had before. The other one would be similar. Yeah. Yeah. Okay, so what do they get if they deviate? So just as before, if firm 1 deviates, he's going to get 10n. And if firm 2 deviates, what's he going to get?
6
Yeah. Yeah, so he gets the total quantity, which is n. He's selling a price just below 10, but he's paying a marginal cost of 4 in each unit, so each unit he's selling is making revenue profit of 6.
What kind of
6 and
6
so for him not to want to deviate, we need these profits from not deviating have to be bigger or equal to the profits from deviating.
It ends up being the same.
Yeah. You've got the answers in front of you. You can check if you haven't done anything wrong. Yeah, so for firm 1 the problem is exactly the same as before. Firm 2 we get there a slightly different way, but in the end it's the same. So both firms are equally tempted to deviate. So we got a half in both cases, that was the captain. Is that what we are?
They get 5 over 6 for
Really? Oh, okay, well that's not good. Okay, so we got a half of the first one. Oh, okay, so for firm 1 they get 5 over 6, but for firm 2 they get a half. So why did we get 5 over 6? We didn't actually do firm 1.
That's true. But it must change, surely, because they now get full profits if they offer a price less than. Obviously, if they offer at 4 or less than 4, firm 2 are now indifferent.
Yeah. So what's happened is the exactly well just what you're saying. So the punishment has changed for firm 1. Okay. So once firm 2 deviates, all firm 1 needs to do is set firm 2's profits to 0. But they can do that by setting a price of $3.99 or $4, just below $4. So even once firm 2's deviated, firm 1 can still make some profits.
Yeah, and that will be the difference. But it doesn't actually make any difference because for firm 2 we still get a half. So the cutoff for firm 1 was no, it does make a difference. That's okay. So the cutoff for firm 1 that the answers game was 5/6. So that's higher. So it's kind of harder to sustain the equilibrium. If we got 5 minutes, let's just go through the problem for firm 1. So if firm 1 deviates, so they start out making 5n over 1 minus rho, just as before. If they deviate, then just as before, they get a profit of 10n. So we don't want them to deviate. No, sorry. If they deviate, they get 10n in the first period. Okay, but then in subsequent periods, firm 2 is then going to punish firm 1. I don't understand the answers. Let me sorry. I'm being stupid perhaps.
Punish them by setting margin. They can only punish them by setting price to 4, which means firm 1 is still making a profit.
No. So this is they can set price. If they, so think about discrete pricing again. Think about they can price in 1 cent. Suppose they set a price of 1 cent.
Yep.
Okay. Oh no, 2 cents I should say. Firm 2 sets the price of.
Firm 2 can't, because otherwise it'd be making no money.
Well, it's only making no money if firm 1 doesn't go under. So it's a bit more complicated actually. So think firm 2 sets the price of 2 cents, firm 1 sets the price of 1 cent. Firm 2 is pricing below marginal cost, but no one's buying from firm 2.
Okay.
So it's fine. So the question is why that isn't an equilibrium. I don't see why it's not. So there's there are probably multiple equilibria to this game. So for one, they're describing firm 2 prices at marginal cost after deviation, which is kind of the natural equilibria, because these equilibria where firms price below marginal cost are a bit weird. Okay.
So how do we get to...
But there's no reason why you can't have the other one as well. So I think the... So the question says, propose trigger price strategies yielding the collusive price of 10.10. Calculate the minimal value of rho but enforce the trigger price strategies you propose. So it's a bit of a bad question because I'm pretty sure there are multiple different trigger price strategies, and that some of them need a different rho to other ones. Because it's certainly an equilibria of a one-shot game for this guy to price at 1 cent and this guy to price at 2 cents. I know it seems crazy because he's pricing below marginal cost, but he's not selling anything, so he doesn't care about that.
But surely if he's trying to punish the guy, then he wouldn't go below marginal cost anyway, would he? Because he can't forcibly drop prices that low without incurring losses to himself. Because he'd be selling units at that price to force one down.
So this, in period 10, say, firm 1 deviates.
Yeah.
Firm 1 knows that he's deviated. Firm 1 knows he's going to get punished for the next period. When you're solving these games, it's as if everyone knows the strategies when you start playing the game.
Yeah,
so firm 1 knows that in subsequent periods, firm 2 is going to set this crazy price of 2 cents. So firm 1 knows he has no choice but to set a price of 1 cent.
Okay.
But if firm one knows that 2 is not going to say anything, why don't firm one just ignore that punishment?
So I don't see what you mean. So if firm one sets any price higher than 1 cent in subsequent periods, they're not going to make any money, because if they set a price of 2 cents from the demand is split between them, or if they set a price higher than 2 cents, no one's going to buy from firm one.
But if at the first place, firm 2 is not going to sell anything anyway in the market, so since like firm 1 would be the monopoly anyway.
But if firm one prices above firm 2, then firm 2 will start selling things. Firm 2 is only not selling anything because they're the most expensive firm. But if firm 1 was pricing above firm 2, then that would be the case. It's slightly strange. The only way you could maybe rule out the equilibrium I was talking about is if it wasn't subgame perfect. But it is, because it's an equilibrium of the one-shot game. So if it's an equilibrium of a one-shot game, it has to be an equilibrium of a repeated game.
So how do we get 5 over 6?
So you get 5 over 6 by looking for a different equilibrium. Okay, I've just confused you thoroughly. So the equilibrium we kind of described when we wrote this is one in which this guy punishes in quite a crazy way by setting a price below marginal cost. It's really strange, but it's a valid equilibrium. There's another equilibrium in which this guy punishes by setting a price equal to marginal cost. So if he sets a price equal to marginal cost, after deviating, this guy is going to set a price of $3.99. Okay, so in future periods, he's going to get the whole market. So he's going to get
N times 3.99.
Yeah, exactly. Yeah. So n 4n over 1 minus rho. Okay. What am I doing? 4n times rho to the t, and this now from t is 1 to infinity. Okay, so he gets 10n the period he deviates, and then in future periods he gets 4n. So this has made deviation more tempting for him. What's the value of this sum? Well, let's just rewrite this as 10n plus rho times sum t is 0 to infinity, 4n rho to the t. Okay, so to start with this sum, the first term of this sum was rho. So as t is 1, so rho, and then rho squared. Okay, so we can rewrite that as a sum that starts at 0 with rho out of the front. See if those two things are the same? Okay, so then we can just use the formula that we know. So that's 10n plus rho times 4n over 1 minus rho. So for him not to want to deviate, this has to be smaller than his profits from not deviating, which is 5n over 1 minus rho. I really think this is right. So let's multiply both sides by 1 minus rho.
Okay.
So this is 10n minus 10n rho plus 4n rho less or equal to 5n. Is that clear? Just multiply both sides by 1 minus rho.
Oh, yeah.
6n rho.
Yeah, okay, so we've got, let's take this over to this side, so 5n is less or equal to, as you said, 6n rho. It's looking promising. N's are going to cancel, so 5 over 6 is less or equal to rho. Okay, so that was the answers that they wanted.
I don't think it was a very well written question.
Cheers.
Yeah, so these games are kind of crazy, right? They have so many equilibria, and you really have to be careful. You better go if you're going to get to your next lecture. Okay, I hope this was some use.
You can give us a mock tomorrow, right?
Yeah, I'm going to write it.